Good afternoon. Yes, I'm Keith Ammons, Business Development Manager for Teltronic. We are manufacturers of professional use radio communication systems and network equipment. That includes also for the transport sector. Actually, I'm in a situation similar to Heikki in that I'm not the person originally designated to present to you today. I'm not Jose Martin. He's my boss. But as it turns out, today he's across the water on the other side of the ocean, and certain problems have prevented him from traveling to be here with us today. But what I want to speak about, as Tony mentioned, is TETRA radio communications for safe and efficient rail operations. Quite a bit of material in the presentation, so I know time is short, and I'll try to go through it as quickly and concisely as possible. What I do want to talk about today, start off just briefly mentioning a bit about the railway environment, some of the challenges that the sector faces, define for you a bit some of the voice and data communications requirements for the railway sector, and then go into why TETRA, what is TETRA, and how is it applicable to the railway sector for communications. Well, looking at different railway segments, it basically can be divided like this. You have mass transit systems, typically for cities, urban environments, metro, light rail, commuter lines, tramways. Then you have long-haul rail for passengers and for freight, intercity lines, and then also intercity high-speed rail lines, achieving velocities of greater than 200 kilometers per hour. In fact, even more, 300 and above. So some of the challenges or even goals in the railway sector would include these: striving to achieve efficient train operations, increasing line capacity, flexibility, no service disruption, as you've heard in a couple of the other presentations this afternoon. Along with that also, safety assurance, no accidents. Accidents, of course, are very bad things to happen in a railway system, so you want to avoid those at all costs. But then that requires continuous monitoring of the trains, of the network, of the signaling systems in your network, and striving to obtain maximum reliability in your system. And then efficiency and safety combined, that contributes then to achieving improved user satisfaction, which is an important goal as well. Decreasing journey times, increasing service frequency, etc., culminating in improved service quality and comfort of the users, of the passengers. But also, it shouldn't be forgotten that whether it's being run as a mass transit system or as some type of concession or as a private business, it needs to be profitable. You need to reduce cost of operation, cost of maintenance, and improve profitability for the system, for the company. Voice and data communications requirements for the railway sector. We'll start off first of all with the voice. Typical voice calls, calls between drivers and the control centers, between the stations, maintenance depots, control centers, and even interaction with the onboard public address systems on the trains, in the rail vehicles, or in the stations as well. Communications for your maintenance crews, communications for your security personnel. All major rail systems have their own security personnel, and in fact, large systems even have their own transit police. So providing communications for these personnel for safety, for security of the passengers, of everyone involved, is also important, and your communication systems that you choose can contribute and cover these requirements as well that are sometimes overlooked. And then related to that with safety and security, interoperability requirements, integration to other networks in the case of emergencies, being able to interact with police services, fire brigades, ambulances, etc., in the case that an accident or an incident does occur. So that's voice. For data, Data requirements for railways can basically be broken down into two blocks. The first block would include things such as location applications, GPS tracking or tracking vehicles by means of beacons and other sensors along the railway, along the tracks. Locating your maintenance vehicles, locating your maintenance personnel who are maybe carrying a handheld radio that is GPS equipped, so you're able to locate them and know where they are at any given moment. Passenger information systems, a lot of data included there, being able to keep your passengers informed and up to date on network status, rail status, scheduling, time of arrival, ETA. And then for safety and for maintenance, telemetry and remote control systems are important as well. Monitoring those alarms, monitoring the status of your vehicles and of your network and of your signaling systems. So that's part of the data that is sent over your communication system. And TETRA, which is a digital radio system that I will get into in a moment, it has lately emerged as being one of the most useful and most applicable radio communication systems to be found today in public transportation systems. The second type of data, or the Block 2 data that we refer to, this would include railway signaling applications for safety and for protection systems such as ETCS and CBTC. So this covers then communication of the protection systems between the onboard equipment and the wayside, communication between the interlockings and the ATS control center, and even communication between the different interlockings themselves, so that your operation systems, so that the trains, the rail vehicles, they are aware of traffic on the line. They are aware if they are allowed to move into the next segment or moving block or what have you. That type of communications is important as well. And TETRA likewise is suitable to meet these requirements. So, why TETRA? What is TETRA, for those of you who may not know? Well, first of all, TETRA is a digital radio standard. It was originally developed for public safety applications. It's a European standard. And in fact, in most countries in Europe today, you have TETRA networks implemented on a national basis for police and emergency services. So that's its origin. But because of the voice and data transmission capabilities and advantages that the TETRA technology presents, TETRA has also been adopted by other users, such as public utilities and public transportation. And it's proven itself quite well. But TETRA, it is an open standard. It's developed and maintained by ETSI, the European Telecommunications Standard Institute. So being an open standard, any manufacturer who chooses to develop and sell equipment based on the standard is able to do so. And there are guarantees in place that this equipment, in spite of being from different manufacturers, is 100% interoperable. It's 100% compatible. So it opens up choices to you, as customers, as communication system customers, to who you want to buy from. It is a digital system, so it offers superior voice quality. It's spectrally efficient in its use of the radio magnetic spectrum. What I mean by that is TETRA, it's a time division multiplex radio technology that is, you utilize 4 slots in a radio channel. Each call, each communication is assigned a separate time slot, but then you're able to support those 4 communications simultaneously in the same radio channel. So it's very efficient in the use of the radio frequency spectrum, and that implies a cost savings to the operators as well, because actually frequency licenses can be expensive. TETRA offers superior security and encryption algorithms, and the standard also defines a variety of gateways to other types of networks and other types of systems. So you're able to tie into IP networks, telephone gateways, other types of legacy radio systems. So you have interoperability with other communications means. TETRA supports half duplex and full duplex communications. So by half duplex, we mean the traditional push-to-talk type communication, where you push to talk and release to receive. It's one-way communication at a time. First you send, then you receive. Or by full duplex, then that's what most of us are used to then when using cell phones. It's simultaneous send and receive. Both parties are able to speak and to listen at the same time. So TETRA does support half duplex and full duplex, and in fact it's one of the few radio technologies available today that does so. Supporting full duplex communication it's not easy. And then other features of the standard: support for emergency calls, different priority levels of the calls, being able to preempt lower priority users in case of incidents, fast call setup, so it's an immediate means of communications. When you want to send a call, the call is established within a matter of milliseconds, rather than saying dialing a number and having to wait several seconds before the other party answers. So it's an immediate form of communications. Remember, it was designed originally for emergency public safety use. So being able to quickly and effectively establish communications, using TETRA is on the first order. And then TETRA also supports simultaneously in the same radio channel both voice and data communications. Some of the standard features defined in the TETRA standards: group management, group calls, broadcast calls. By that we mean system-wide calls, being able to broadcast a message to everyone in the network simultaneously. Fast call setup, I mentioned before, always less than 1 second. In fact, usually it's on the order of about 300 milliseconds. Priority management, I mentioned, emergency calls, different types of data services. Among those are the ability to send and receive IP packet data, circuit mode data, which is kind of data streaming over the radio channel, status messaging, and short text messaging, the same type of short text that you would send with your cell phone. I won't go into all of these, but duplex calls I mentioned, very useful for hands-free operation. So you can imagine a driver being able to speak in full duplex without having to use his hands to control the radio communication. He can concentrate on his task at hand. And direct mode, this is a direct one-to-one radio-to-radio means of communication, which is very useful in maintenance yards, rail yards, for shunting operations. So compared with other technologies that you find being employed in the railway sector, it's such as Wi-Fi or GSMR, TETRA is an excellent comparison, and even offers better performance in different aspects, such as reliability. It's a proven technology. It's been around for more than 10, almost 15 years now. It provides protection against interference from other systems, from other radio channels. Offers good quality of service, availability. Its architecture allows for multiple layers of redundancy, so therefore you don't have any single point of failure. A wide variety of frequency bands. TETRA is available in a wide variety of frequency bands, particularly in the UHF band. I'll come back later on why that is important. Mobility, scalability, IP-based system, so that's the modern system. And open and multi-vendor, I mentioned that before. There's a wide variety of choice for TETRA equipment in the market. If you look at other technologies, however, like GSMR kind of originally began as an open standard in that it's based in general on GSM telephone services. The R means rail, so it's a railway variant of GSM. So that kind of narrowed the field of the number of manufacturers of the equipment. But it did kind of start out as an open system, but over the years the field has kind of narrowed down, and basically if you're talking about GSMR, you're basically depending on one primary manufacturer. So it's not really sole source, but you're very limited in the choice, compared to TETRA, where you have 8 or 10 manufacturers rather than 1 or 2. So some details then about ETCS and CBTC and how TETRA can be applied. Looking first of all then at protection systems based on radio communications, you have the wayside equipment, and this then processes the information received from the interlockings and the APS, and it sends the instructions to the trains. And then on the other side, on the onboard side, they execute the driving commands based on the information that they are receiving. So the train receives in advance the information from the wayside with its instructions, with information about whether it's able to proceed along the line or not. And it is continuous data transmission, and it's important that this continuous flow not be interrupted in order to obtain efficiency and safety in the operation of the rail line. Some examples of protection systems found today. ETCS, this is the European Train Control System. As its name implies, it is found primarily in Europe, and it forms a part of the ERTMS system. And it's designed primarily for international cross-border type operations. CBTC, communication-based train control, kind of a standard, yes and no. I wouldn't say it's a 100% standard across the board. As CBTC, it's really directed to a different market than ETCS. CBTC is more found for urban and metro systems, and so it is logical then that there will be small variants, from system to system. But it is starting to be unified as kind of a standard. And then PTC, Positive Train Control, which essentially is ETCS, but it's the United States version of ETCS, developed in parallel. Looking at ERTMS, the European Rail Traffic Management System, it's formed by two parts. ETCS, as I mentioned, which is the control system, the protection system, but that's combined then with the communication system. I mentioned GSMR, and that is the standard that is prevalent today, at least within Europe. ERTMS, it was a EU initiative to unify rail command and control communications within the European community and neighboring countries. So its focus is on international, especially cross-border operations, for long-haul rail lines. Why GSM? Actually, when the choice of technology was made, GSMR and TETRA were the two main technologies being compared against one another. But what happened? This took part in the mid to late 90s. GSM had been around for several years, was well known. TETRA was new; it was just getting started. And even though comparing side by side the two technologies, their feature sets, what they're able to do, on paper, TETRA can be seen to be superior in many aspects to GSMR. But at the time that the technology was selected, at the time that the standard was developed, people knew GSMR. It was the more mature technology at that time. TETRA was new. They didn't quite trust it yet, so the decision was made for GSMR. Today, however, TETRA is seen to be a well-proven and mature technology, and so as GSMR systems are aging, it opens the possibility that maybe TETRA is able to move in and take over some of that responsibility as far as being the communication system. GSMR, and this is getting back then about the frequency bands, it's found in the 800 and 900 megahertz bands, or even higher, whereas I mentioned that TETRA is found in UHF frequency bands, 400 megahertz range. Why is that important? It's important because of the communications range. Basically, the lower the frequency, the longer range. So TETRA being able to operate in lower frequency bands, by laws of physics, then allows you, in principle, greater communications range. What does that mean? Well, it means that you don't need to have as many transmitter sites. You're able to spread out your transmitters and cover wider areas, so it reduces your communications infrastructure costs. So let's look then at the ERTMS basic requirements. What are they? What does the ERTMS standard ask for? It asks that it be an international standard, which it is, proven effectiveness, economic viability, open standard in a multi-vendor market, special services that are adapted to railway needs, integration of railway services into a unified, unique communications network, high level of reliability and availability, even at high speeds, and capability of easy integration into new systems and services, being future-proof, being able to grow. Why GSMR in Europe? I just covered that. But what happens in other rail environments? As I say, GSMR, it's used in ERTMS, and it's mostly focused within Europe, in some other parts of the world, but primarily in Europe, and its main focus is on long-haul international cross-border communications. But does that mean that any type of rail system that is used has to be GSMR? Well, not necessarily. I mean, does a local network, a city network, or even a regional or small national network, does it have to use GSMR? I mean, there are other solutions out there. And so what we're proposing, the focus of this presentation is we are proposing that TETRA pick up some of that. And in fact, TETRA is being used now in some parts of the world. Not in Europe, because GSMR is well entrenched. But in other parts of the world, Asia in particular, Africa, South America, and possibly in the future North America, TETRA is starting to make inroads. Okay. So I mentioned before the list of requirements that ERTMS is requesting, and this is the list of features that TETRA provides. And as you can see, it's a perfect match. So functionally speaking, TETRA does fully comply with the ERTMS standards and requirements. This is just some technical information about GSMR. Call establishment. I mentioned call establishment. That TETRA, it's more or less an immediate push-to-talk type of technology. Call setup time is very fast, always less than 1 second, typically even less, on the order of about 300 milliseconds. GSMR, let's see, this comes from the ERTMS requirements. They are asking for call setup time of less than 10 seconds. So 10 seconds, that's a long time compared to 300 milliseconds for TETRA. So why was that put in the standard? Well, because it's what GSMR complies with, and that was what was available at the time. But technology has since then advanced, and TETRA offers much more immediate and more responsive communications. So TETRA supports ETCS requirements for communication systems. It offers a variety of data services that are of interest to the railway sector, because there are data requirements for wayside and to train communications. And it's more cost efficient. It's more spectrally efficient. It's more efficient in its use of the radio spectrum. It's more efficient in the coverage that it provides, the radio coverage it provides. And so it implies a cost savings because you don't require as much network infrastructure as for shorter range technologies. So GSMR, as I say, it's only mandatory within Europe because the EU says so. But in other parts of the world, TETRA is a viable alternative. Now, if you thought that was the end of the presentation, I'm sorry, it's not. Just a couple more points briefly about CBTC, and then I'll wrap it up. But about CBTC, as you can see, on the face, it's very similar. The model is very similar to ERTMS in that you have the protection system, in this case CBTC, and then that's matched with a radio communication system. CBTC, as I mentioned, however, rather than being focused on national cross-border long-haul systems, CBTC is more oriented to urban and mass transit environments. So that also implies higher degrees of traffic, higher density, higher intensity of traffic. And each signaling manufacturer has developed its own solution. So it's kind of a standard, yet it's not. There are slight differences between the solutions available. But there are various communication technologies that are being used. Some of these are proprietary, some are open standard. Some even involve Wi-Fi. What about Wi-Fi? Well, Wi-Fi it's great. It's great to have Wi-Fi available in a metro system because the passengers they want to come on board. They want to use their cell phones. They want to use their iPads. They want to to be able to download YouTube and read the news and things like that. That's great. But is Wi-Fi really adequate for signaling and safety? Well, maybe yes, maybe no. But you have to consider some things. That a lot of times Wi-Fi it's operated on unlicensed bands. So that means that it's open to interference from other users and from other systems. And then Wi-Fi also runs into the other problem that GSM-R can be said to face, and that's communications range. Wi-Fi systems are typically low output power and operating at very high frequency. So that means your effective transmission range is probably on the order of about 100 meters or so. So that means you have to have another transmitter every 100 meters. Okay, that might be fine, in some cases, but that can be pretty expensive for very large systems. And as I mentioned, TETRA it offers operation in a different, longer range frequency band, and your cell size, say above ground, can even be a 15-kilometer radius. Underground, of course, it's still longer range than this, but much better than 100 meters. And TETRA is based on an open standard, so it's not a proprietary solution in any way. So in the same way as ERTMS, TETRA can also support CBTC data requirements. It's reliable and provides high availability, flexible. And again, there's no mandatory radio technology for CBTC. However, we do feel that TETRA is a viable solution. And so just to summarize, what can you get from a TETRA railway solution? Well, you can get a full turnkey solution. The TETRA network infrastructure for voice and data communications, above ground, in tunnels, the onboard equipment as well, other types of radios for use in the stations or by the maintenance crews, maintenance personnel, maintenance vehicles, control center, ATS, operations center applications. And in a turnkey project, we also offer complete project management as well. Customer-oriented projects, railway projects, they're always personalized. No two are ever the same. Every customer is different, and you have to adjust to the customer's needs. Railway signaling by TETRA then offers safe and efficient operation. And here's just a list of several rail cases using TETRA. Some of these are also being used with Kazakhstan Railways, for example. They are using TETRA to control the moving blocks. So you can see the application of TETRA in railway systems. Okay, thank you.
Okay, thanks very much.